Good morning, good afternoon, depending on which part of the world you are. A quick introduction of myself. I'm Subhro Mitra. I'm professor in University of North Texas at Dallas. Um, the topic of my presentation is optimizing agricultural freight flow from farm to fork. So, as the topic of the presentation says, we are dealing with agricultural freight and we'll try to optimize the flow from farm to fork. So basically end-to-end movement of agricultural freight. So every agricultural supply chain is little different from conventional supply chain. It is much more complex with a lot of uncertainties. It's much more fragmented. Uh, because we have small producers, and especially if you uh, deal with countries outside the United States, especially in Asia like China or India, you'll find a very fragmented manufacturing of agricultural freight. Like the farms are small, very small in size. Um, each of them have their own objectives to maximize their profit. They don't have knowledge of the whole process, so that way they cannot really optimize their profit, or which in turn does impact the overall system. There's a lot of uncertainties as well in this agricultural supply chain. Uncertainties happen because of variability in the yield, which is again depends on so many factors. uh, the inputs of the farms, which are also very uncertain. The price is volatile. It depends on the supply and demand, and it changes a lot. So in brief, this agricultural supply chain is very different, and there are some specific knowledge which is required to build a very uh, or develop a true depiction of the agricultural supply chain. So if you take a look at that figure, which is on the bottom of that slide, um, so the supply chain begins with uh, collecting of wheat. It can be any other agricultural product, from which it goes to the silos. From the silos, it goes to the processing plant, the flour factories. Uh, from there, it goes to the demand center. Now, the demand center can be a bakery, or it can be a retail outlet where people can go and buy the processed wheat. So, based on traditional supply chain, we can divide uh, this into two parts. The upstream would be the farm or the production location, and also the silos. The downstream would be the factories and the demand center. So if you take a look at this figure, we see that um, there are, if you go back to the supplier of the farm, so there are a number of supplies required for production. It can be seeds, it can be fertilizers, insecticides, and many other additional products which are required in the farm. The farms are fragmented, uh, and especially in Asia, they're of really small size. And then it can either go to a manufacturing location from the farm, but again, that instance is very low. For most cases, it goes to a broker who determines the price. Um, and from there, it goes to the wholesale market. From there, it can again go to a processing plant, it can go to a retail store or in a restaurant. Now, these brokers here in between, um, they probably consume, or uh, they each have a big part of the profit of the producers. So a end product which is sold maybe $10 a pound, maybe the manufacturer or the farm owner, he's getting just $2. The middle players in the market, in the supply chain, especially these brokers and uh, the wholesale market, they eat away a big part of that pie. Uh, so there had been, if there is effort in different parts of the world so that these brokers and the middlemans, they can be eliminated, and the the farms get a bigger, better picture of what is of the supply chain, so that they can send it maybe directly to a processing plant, who in turn can send it to the retailers. Uh, but again, because the farms are so small, there and there's not much of collaboration between them. So uh, going to that level of understanding the whole supply chain and getting advantage of this movement directly to a manufacturer is not always possible. So if you take a look at the value chain, um, we have the agri inputs, then we have production, processing, and the market. So every player is supposed to add some value for the whole process. So we have looked into the market and seen that, well, the brokers, the value they add is not really significant compared to the profit margin which they make. So as I said before, that a concerted effort is needed for the farmers to sell their product directly to the manufacturers or the processing plant so that they can maximize their profit. The food value chain may look like a traditional supply chain, but again, it is different, and um, it's quite different from that of a manufacturing supply chain. The shared mission and operational value support decision process. So shared mission is difficult to achieve because they don't have that knowledge and often fails in collaborating with one another. The other thing which we had been doing a project for India, and we have seen that this agricultural supply chain is just not a just cannot be looked from the business perspective. There are a lot of economic, there are a lot of local economy, there are a lot of traditional values, uh, traditional way of life which is associated with this agricultural production. And there are some deep-rooted problems which is really difficult to eliminate. We can build a model, we can run it and tell what to do, but to actually implement that is a real challenge. Um, we had been approached by some uh, government and semi-government organizations to take a look at the agricultural supply chain and understand first the value chain. As I said, the value chain is the addition of value at every point, and what actual contribution each of those players in the supply chain are doing, each of those value chain are doing, and then take probably a higher level perspective of this value chain in terms of the supply chain profit maximization and lowering of the transportation cost. I think I should point, give one important point here. The amount of food that is wasted in any of these Asian countries like China and India is just tremendous. Um, there is one statistics which said that the food wasted in India in insufficient transportation and storage facility is equal to consumption of whole of Australia. So that fact itself says that there is so much of scope of improvement of transportation and um, inventory management in terms of agricultural freight, so that that loss of agricultural freight can be minimized. So in a country where Food is such a big problem. Like there are so many people who don't get uh, access to the right food. In that country, the food is wasted. So that's really something which is not acceptable. So I think transportation planners, supply chain planners has got a big responsibility and a role to play to minimize that loss of food, maximize profit for the farmers, and improve the efficiency of the system as a whole. The customer feedback, the market intelligence are gathered at the point of sales and shared among the value chain partners. So the knowledge is to be transmitted to the different players of the supply chain so that they can take a better decision. The suppliers gain advantage in responding more quickly to customer needs and buyer requirement. So oftentimes this is not possible, or this is not the suppliers of doesn't have enough of information, so they take a lot of wrong decisions, and which in turn leads to a lot of wastage of agricultural freight. The farmers who receive a greater share of the consumer expenditures have more discretionary income to spend on the local goods and service. So as I said, like the farming is such a backbone of the economy of many of these countries. So if the farmers can get a bigger share of the profit, so that in turn will go a long way in making the economy stronger. Again, we should understand the food shortage, the wastage of food is not only a problem of developing countries, it's a problem with many uh, developed countries as well. There are food deserts in US. So uh, in a previous project, we had worked with some of the food banks and identified areas where their food shortage and uh, what their food desert, like people doesn't have access to the right food. So even in the developed countries, agricultural supply chain is to be improved, and there is a lot to do in many areas. So for this project, what we had done, we had tried to develop a data of crop production from the satellite image. So this crop layer is a rasterized data layer in the GOT format. Uh, what we did is extracted individual crops. This is a mosaic layer, so we extracted individual crops from that from the crop layer, and then we uh, use that to generate the amount of agricultural freight which is generated. So we overlaid this individual crop layer with a grid, 1 mile by 1 mile grid, and estimated the crop production area. Okay, so which gave an understanding of how much crop is grown in each of these grids. Okay, so we also have information of the silos or elevators, which are on the storage locations. We have information about the processing plant and also the final demand. Now the final demand can be a export location, which may be a port, or it can be a city location where there is a lot of consumption of those processed agricultural product. So over here we see that the grid um, is laid over the crop data layer, and the crop coverage in each of these grids are estimated. So we developed a program which calculated the area of crop coverage in each of those grids. So this is a snapshot of the GIS data. So each of those, the algorithm which we developed that estimated the crop coverage for each of those crops separately. Okay. Now, we had seen that there is a lot of error in many of this data. I'll not go into that discussion, but we tried to develop a error factor and utilize that to calculate the actual production. So over here you can see that we have information for demand, we have information for source, which is again the farm locations. We have the mills, which are the processing plant. We have the elevator locations. We have ports. Again, as I said, the demand can be um, a port or it can be a city where the consumption takes place. One more thing which I think I should mention here is a lot of these elevators have got railroad connectivity. So from the farm it goes to the elevators, and from the elevators, from the farm usually it is trucked to the elevators, but from the elevator they have the option of either using railroad or truck to the next destination, which might be a processing plant. So a mode choice model is required to understand the proportion of freight which would be moving in rail and which would be moving in truck. So this is the model which we used for estimating the crop production in each of those sections. So we have this area, like the A is signifies the planted area of crop in a particular section. We have this yield. The yield can be the published yield. It can be, again, the yield can be forecasted using satellite image, and P is the percentage correction factor. So we summed up the production for individual counties, which is again a published data which is available for many states. And uh, we found a correction factor from our estimation, and we use that to correct the production for each of those sections. This is a optimization model which we have built. Again, we have number of optimization models. So one over here is the the cost minimization model using different trucking configurations from the farm to the elevator and from the elevator to the final destination. And we had some of the constraints, which is the capacity of the truck, capacity of the silos, matching the demand and the supply. So we developed number of those optimization models to understand, to minimize the transportation cost and to maximize the profit margin of the farms and also for the elevators. We also did some greenfield analysis to identify location of the silos. Now, there are some existing silos and there are some new silos coming up. Now, silos have a big advantage for storing agricultural freight. Especially in the Asian countries, we have seen there are new silos coming up, which is a new concept here. Sometimes they're built in a public-private partnership, but it has got an immense impact on the agricultural supply chain in many of these developed countries. So the greenfield analysis was done to identify location of these silos, and we also found how much cost saving can be done by um, identifying the right location and saving in transportation cost and saving in inventory cost. So this is the model which we ran in anyLogistix platform. So we did both greenfield project network optimization model, simulation model, and also a transportation optimization model. Now, the transportation optimization model was done to find the different, uh, identify which trucking configurations uh, give the best option to lower the transportation cost. The simulation was done to find the service level and to develop different KPIs. Uh, Again, the agricultural KPI is different from manufacturing KPI, and sometimes we had to develop our own standard for agricultural KPI. We did the network optimization model to match the demand and the supply and see what was the total profit. So for each of these, we had to substitute with different ground data. But again, as I said, like each of those production locations are fragmented. The data which developed from the GIS satellite image may not be always applicable because each of those farms have got their own objective, and the collaboration between the farms are very low, or it doesn't exist at all. So in that case, many of these models won't really work. Again, right now there is an uh, effort by the government and many of the different business houses so that they can unify this fragmented supply chain in a more optimized format. So we ran number of models. We showed them what was the cost saving. So this is one data which we extracted from the anyLogistix model which we ran, and we saw we showed them what was the cost saving. There was a transportation cost saving of 6%. Well, it is a huge saving if that can be achieved. Millions of dollars, because so much of transportation cost is involved in moving the crop freight from the farm to the elevators. So there had been, as I said, like also about the trucking configurations. When we consider the trucking configurations, the load restriction of the roads the trucks move, that also plays a big role. The payload of the truck, the exact equipment required to load uh, each of those crop freight into those trucks, because each of the crop can have their own different requirement. So based on that, uh, we ran different transportation models and tried to develop some consensus among some of the key players who are involved, and showed them what the cost saving that can be achieved, and how much is doable on that part. We developed different KPIs. We ran the simulation model, showed them different service level, what changes can be made so that they can improve the service level. Okay, so probably that's something which we are still working on. There's a lot to do, as I said, like it is to implement many of these models uh, in the practical world is very difficult because of this fragmented structure. There are so many uh, complex relationship which exist between each of these supply chain players. And my presentation ends there. I'll probably take a look at the questions.
Thank you very much for this presentation. It really like what impressed me, how this agricultural specific field of implementation of any logistics requires to extract the data. So from GIS system, from satellites to estimate. So I believe this might took a major part of your project, or it was not the major part. I mean, time consuming, of course.
So we see some questions here. What kind of data do you transport back to the ERP system? Um, well, we are still working on that. Like, um, again, as I said, like many of the ERP system, this um, agricultural manufacturing plants work. They're they're so diverse. They have their own legacy system, and they don't really talk with one another. Um, and we haven't really integrated most of the systems yet. So that is yet to be achieved, but that's a very good question. We plan to develop a different set of ERP tool to handle this agricultural supply chain. The combination product, customer, manufacturing plant, so the distribution network planning tool replicate the optimal solution in production.
Yeah,
Well,
yeah. Thank you very much for this answer. And maybe one question from our team. So could you please share insights for the, I know, for the future listeners of your speech? So, what is the time frames took your project? So, like you said, from farm to fork, and like we usually asked, what time does it take to make any logistics scenario and the whole project with the data stage, processing stage, model creation and outputs and all these experiments. So what are your estimations and
so
how long
this
did it take
this that,
for you?
that's a good question. So
Mm-hmm.
this project went for almost a year, and big part of the time went in gathering data and understanding the complexity of those um, the different players in this value chain. Um, Once we had the data, building the model was in any logistics. Any logistics is such a user-friendly tool, so it was that didn't take us much time. So the main time for us went in developing or understanding the complexity of the supply chain because it's so different from traditional supply chain. Uh, I would say implementing the model in any logistics took us probably a little more than a month, but the gathering data is where we had a lot of challenges and it took us a long time.
Thank you. And there are like many questions, many more questions in Q&A section. So it would be appreciated an answer. I will read it for you. So first off, thank you for this presentation. Could you please explain the role of the data extracted from GIS and how you integrated it into anyLogistix?
So the integration was not direct. So we extracted individual crops from that crop data layer and developed our algorithm to estimate the crop production for each um, square mile of the grid. Um, use that for the the the, the trip generation of that. So we converted that, say there is a crop yield in tons, so that help us understand how much each of those grids are producing. From there we that data which we developed outside any logistics, then we export that into any logistics and then run the model. So big part of the GIS data analysis was done outside any logistics.
Thank you. And one more for our participant asks if you have some references or published work or any published papers so far about this project, so we can gather more
Uh,
information. Yeah,
no,
about.
this we are still working on it. It's not published yet, but probably we expect that to be in the coming few months. We'll be publishing a paper on this.